Okay, welcome class. Good morning. Sorry I couldn't be there today, but thanks for watching the video. Pay very close attention, and when I tell you to pause, pause the video, work it out, and then you can unpause it, and the answers will show up shortly thereafter. Okay? So this is your warm-up, so go ahead and answer these questions on your own, on your piece of paper. You can talk with your friends if you need to get some help, maybe, but you got this. Okay? So pause the video now. Okay, so these are the answers to the warm-up question. Thank you for pausing the video because I know you did that. And one thing that I want to point out is I didn't really stress it yesterday, but I feel like it should be a point of emphasis. Make sure that you put y to the negative 1 when you do that, or the inverse of y, when you write your answers. I didn't really stress that yesterday, and I should have. So make sure that you do that from here forth. Whenever you write the inverse function, put y to the negative 1 or f to the negative 1 of x. Okay? So just pause if you need to slow down and keep going. And we're going to move forward. Alright, so today we're going to explore functions and their graphs through the table, and their inverses through tables and graphs. Some key vocabulary that you need is the word invertible. Invertible. A function is invertible if and only if its inverse relation is a function. Okay? So basically, it's saying that we start out with a function, and then the inverse of it is a function as well. Well, what does it mean for it to be a function as well? It's 1 to 1. So a function for which every element of the range, these are the y values, correspond to exactly one element in the domain, the x values. So basically, normally you look at a function and you look at the x values and you check to see if it only goes to one y values to see if it's a function. Well, now for it to be 1 to 1, the y values also can only go to one x value. So if a function is 1 to 1, it is invertible. And that's how these two are related. Okay? So one way we can do it is you can check it by using the vertical line test and the horizontal line test. Okay? We've done the vertical line test before. You just make a straight up and down line as long as it only hits once. It is a function. For it to be 1 to 1, it also needs to pass the horizontal line test. And you can see right here that ours does not pass the horizontal line test because it touches in 3 spots. Okay? So this function is not 1 to 1. But just like on your homework, you guys asked me, what does this y greater than 0 thing mean, and things like that. So what that means is there are certain spots that we can limit the graph to where the function will be 1 to 1. Okay? And so what you'll do is you'll look at this graph right here, and we can see that this one can be 1 to 1 as long as it goes to here and it doesn't go past this point right here. So anything left of this is still a function horizontally. Okay? So that means its inverse, anywhere from negative infinity to this point right here, is 1 to 1. So what we can do is we can limit the graph so that it only counts up to here. Or we could cut it off from here, and it's still a function all the way through until it gets to this spot right here. Basically the vertexes, the turning points. These are going to be our limitation numbers. So it's 1 to 1 from here to here. And then we'll see that from here on, it's also 1 to 1. So at any one of these 3 little positions, position 1, position 2, or position 3, or zones, it's 1 to 1. So we can limit the graph using the inequalities like y is greater than blah. And we'll use the y values here because remember the y values of our regular function become the x values of our inverse function. And so that's how we'll limit the domain of the inverse function, is we limit the y values of this function. Okay? So, is this table invertible? Does the inverse function exist? Okay? So, in order for it to exist, it has to be invertible, which means it's 1 to 1. Okay? So, all our x's don't repeat. So, if the function itself is a function, okay, or the table itself is a function. So now what we need to do is check the y values and see if they're also 1 to 1. Okay, well, since none of the y values repeat, it's automatically invertible because there's no way it could show us that 6 goes to something different than -2. Okay, so the table is invertible, yes. Okay, so does the inverse function exist? Yes. Okay, if it's invertible, it exists. Okay, so when we're doing this, when we find the following, it's like normal, okay, but what we're going to do is, if it's saying find f of -4, well, our table is the f function table, so we'll do just like normal. This is our x value, okay, and so where x is -4, that goes to 12, okay. When it says f inverse, okay, that's kind of like the opposite. Instead of starting with our x value, when you do f inverse, we'll start as 12 being our y value. So we'll go down to where 12 is here, and we'll go back to find the other one because we're doing the opposite, okay? And so that's 4. So then this one asks for the f inverse of -9. So see how we have two different -9s? We start with the one that's at the y value because it's the opposite of this one. So we'd go start here and go that way. And so you'd end up with 3. If you feel like you would get confused, you can create an inverse table yourself. And you just switch the values. So this would be 27 and -9, 12, -4, 6, -2, and 0, 0, and -9, 3. Okay? And so then you said that function evaluated at 12 is -4, the function evaluated at -9 is 3. Okay? So then, I guess, looking at this next one, is the table invertible? Okay? So that means we're going to look to see if these are 1 to 1. And the answer is no, it's not invertible because -4 goes to -1 and it goes to 2. -6 goes to 0 and it goes to 1. So it's not invertible. Thus, we will not answer these questions here. Okay? Not all tables and functions that we give you will be invertible. So you're going to answer this question on your own. So I need you to pause the video now, and I'll come back to you in just a second. Okay, so this function is invertible, so it's 1 to 1, which means it does have an inverse function that exists. Okay, so whenever you're looking at it, make sure you pay attention to whether it's asking you to find f or f inverse. So if it says f, just go normal. So f of 1, just go to 1, 1 goes to 4. Bam, done. f2, it's normal, so you start at 2. What does 2 go to? It goes to 1. Awesome. So over here, question number 4, it says f inverse of 3. So that means we're going to start with the y value, and then wherever it's 3, so 3's here, and we'll go up, and the answer is 0. So let's find the inverse again. So we go to 4 on the inverse, and that goes to 1. So now you can summarize here what that means to you and what you need to say to yourself so that all that makes sense based on what we just did. Okay? So now, we're given the graph, and we're asked to find the inverses. Okay? It works pretty much the same way. The key here is you want to make sure you focus on the f of x part. Okay? So, this is given to you. This is the normal f of x function. So this function represents the normal one. Okay? So, pay attention to what it's asking you for. Here, this one asks you for the f inverse of 4. Okay? So that means we'll start at our y value. If they are opposites, you will start at the y value. If they're the same, then you'll start at your x value. So f inverse is the opposite. So 4 really is our y value. So we'll start at 4, and we'll go across, and then wherever the function hits, that's where we'll go down, and that's why the answer is 2. Okay? So then we'll go to the f inverse of 6. It's the inverse, and that's the regular. So these are opposites. And so we'll start at 6 on the y value. And so we'll go to y value here, and we'll go across until it hits the graph, and then it'll come back down, and that's at 4. Okay? So this says find f of 3. Well, these match. This is the normal one, and that's the normal one. So that means we'll go to 3 on the x-axis. So we'll start at 3, and we'll go up. It's here, and that touches at 5. And that's why f of 3 is 5. Okay? Example 2. I want you to do this one on your own. So pause the video, and come back to me when you're done. Welcome back. So the answer to f of 1 is 2 because it matches what it is. So we go to 1, and we go up, and it's at 2. F of 2, same thing, it matches. So we go to 2, it goes up, it goes to 3. F inverse of 3, so these are opposites. That means we start with the y value. 3 goes to 2. Okay? F inverse of 4, same thing. These are opposites. So you start at the y value, go, and then that goes to 3. And that's why those answers are what they are. On your own now, answer this question. You got this. Okay? Especially after that last one. And I'll see you in a second. Okay. So, notice how this one is the inverse function. Okay? So, f of 1, these are opposites. Okay? So, we start with the y value. And so, when it's at 1, the thing's at 0. Okay? When it's at 2, these are opposites again. You start at 2, and it goes over to 3. Okay? F inverse of 3, well, these are the same. So you do normal starting on the x-axis. Okay? So 3 goes to 2. And F inverse of 4, these match. Okay? So you start at 4, you go up, and that's at 3. Alright, so this one, I want you to take your time, go through, answer this question. It is not as hard as you are, but the question is, if the cost per cake for a certain event is $22.50, how many people are expected to attend the next event? Okay? So use the information provided and inverse your way back to the answer. Pause the video. I said pause the video. Okay, so one of the things we can get from this is $22.50 is how much the cake costs. Down here, this is where cakes cost something. Okay, and so how many people are expected to attend? Well, the cost function only tells us about the number of cakes, and then the number of people tells us how many cakes. So if we know the number of people, then we know how many cakes. Okay? If we know how many cakes, then we know how much we cost per cake. So now what we're going to do is we're going to inverse that. We're going to go backwards towards the original answer. Okay? So if we know it's $22.50 per cake, then we know there are 6 cakes total. Okay? So if we know there's 6 cakes, we go backwards, there's going to be 144 people. Because remember, inverse means we just work backwards. And the way this started out was it started out with number of people, get the number of cakes, got the number of cakes, get the cost per cake, and then we went backwards. Okay? Thank you for watching the video. You now need to answer questions 1 through 10 on the worksheet that's underneath this video link on my website. Thank you guys. Have a great day. I hope this helps, and I hope you understand everything when I come back on Monday. Have a great weekend. Be safe. Go to church.